Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now, I can take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Counting Line by Jolly Rogers, and here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or 9-cell region. We also have a digit on the line indicates how many times that digit appears on the line. So for example, if you saw a 6 here, you would know that a 6 has to appear on this line 5 other times because you have to have 6 sixes in total on this line. And that's how this counting line works. We also have digits joined by a black dot have a 1 to 2 ratio, have a ratio of 1 to 2. So these are typical black Kropke dots, which meant if this were, say, a 4, this would have to be a 2 or an 8 to make sure that this has a 1 to 2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So on this counting line, first of all, let's see. How many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There are 30 digits on this counting line. We know there's at least 5 unique digits in each of them because this has 5 digits in this region, which are on the lines. This is 5 also, and this is 5. So it adds up to 30. All the digits on that can be on this line must add up to 30. Let's see. Actually, there are 1, 2, 3, 4, 5, 6, 7 unique digits on this counting line. At least. So that means 2 digits are not on this counting line. And you cannot have 9 be one of them, right? So that would mean, I think it has to be then 7 and 8, right? We have 30 digits. We have to include 7 of those unique digits. That means the other 2 digits cannot be on this counting line because you have 30 digits on this line. Each one counts for however many whatever number it is, right? So 1 would count once, 2 would count twice, 3 would count 3 times, etc., etc. Therefore, if you have a 6 or a 9, well, you can't have 9 because you can only have 9 nines and one of them is in the central box. So to add up to 30, that means you have to subtract out a 9 and a 6 because we know 7 unique digits are on the line at least. So that means only 2 digits are not on the line. And therefore, it has to be 6 and 9 because 9 can't be on the line. Therefore, 8 is on the line and 7 is on the line. Well, where can 8 be on this line? You can't have it in the central. So in this box 3, 8 has to be the only digit there, which means 7 also has to be on the line in all the digits. So 8 can't be here. 8 has to be one of these 2. 8 can't be here, so that means 8 has to be one of these 2 in box 9, which means none of these can be 8, which means forces 8 to be here in box 6. 8. Where can 8 be in box 1? It's one of these 2. Where can 8 be in box 4, it's one of these 3. Where can 8 be in here? It's one of these 3. Okay, so where's the possibility for 8 in column 1? It can only be here, and it must be there because otherwise the only 8 that's not on the line is in box 5. So this has to be an 8, which forces neither of these to be 8. Therefore, 8 can be in box 5, one of these 3 cells. Where's the 8 in row 9? We know there's a 8 in one of the digits in box 8 because it has to be on the line. So one of these is an 8. We know in box 2, the 8 has to be in row 4 and 6, or columns 4 and 6. And the same for box 8. The 8 has to be in columns 4 or 6, which eliminates 8 from the rest of columns 4 and 6. These can't be 8. Whereas the 8 in box 5, it has to be here. Okay. We know 9 is never on the line. So where is the 9 in column 2? It cannot be in a 1 to 2 ratio with anything. So it cannot be here. It must be here for column 2. In row 8, it could be either of these, so that's fine. Where can it be in column 4? It can't be here because of the 9 in the row. Can't be on the line. Can't be next to black crop key dot, so it has to be one of these 2 digits in column 4. Which means, where is the 9 in box 2? Can't be in either of these because of the 9 in the row. Can't be on the line. Can't be next to a black crop key dot because 9 is 4.5 doubled, which is not a digit. And if you double 9, you get 18, which is not a digit. So 9 has to be here, which means 9 is one of these 2 digits here in row 2. That means in box 8, where's a 9? It can't be here because one of these 2 is a 9. Can't be either of these because of that 9. So this must be a 9 here. That means 9 cannot be here or here. But 9 still could be either of these 2 digits here. And it could be any of these 4. That's fine. 6 is also not on the line, but it's not as restrictive. Oh, 6. Where's 6 in column 2? Can't be on the line, so it has to be here. So this is 6, which makes this a 3 to maintain the 1 to 2 ratio. That's 3 in the corner. We celebrate because we know we're getting close to solving it. This can't be 6 here. Where is a 6 in row 8? It can't be on the line, so it must be here. So this is 6, which means 9 can't be there. Therefore, that forces 9 to be there for row 8. Where is the 1? One has to appear on the line in row 2, sorry, column 2, and in row 8. Well, where is the only place it could be 1 on there? It can't appear on the line twice, so it has to appear once, which means 1 has to be here. 2 has to appear twice. And therefore, the 2 has to be one of these digits and then one of these digits here. So the rest of the digits on the counting line cannot contain a 2, which doesn't really tell us much. In box 7, what are the digits? They have to be a 7-8 pair. Because otherwise, there is no... 7 has to appear on the line in every other box. Because it can't appear here, and the 7 here obviously is not on the line. So all the other 7s have to be on the line. So this becomes a 7-8, 7-8 pair, which eliminates 7 and 8 from the rest of the box. This is 2, 4, 5, 2, 4, 5, and 2, 4, 5. 7 has to be one of these 3 cells. Oh, 7, okay, where's 7 in row 9? It has to be one of these 2 cells here also, along with the 8. So this is specifically a 7-8 pair, not 8-9. It's a 7-8 pair here. Same with row one, column 1. Where is the 7? It has to be on the line because, again, it can't be on the line in box 3 and box 5, so it must be on the line everywhere else. So this is 7 here. 7 has to be then one of these two digits. Where is a 7 in box 9? Can't be here, so it must be here. So this is 7, which makes this 8, which makes that a 7. This 8 eliminates 8 here, so this must be an 8 here. 7 cannot be here, so 8 cannot be here because of the 8 on the column, so this is an 8, which forces this not to be 8 here, which makes that an 8. Whereas a 7 in row 1, it has to be here. Because again, actually, no. Yes, actually, even with box 3. So the reason why column 1 works is we know 7 has to appear on the line in box 1, 4, and 7. If 7 were any of these in row 1, 7 has to appear on the line in box 1 and box 2, but it doesn't appear on the line in box 3. But if we try to have a 7 here in row 1, it's eliminated because of the 7 already in the column. This can't be 7 because 7 is only double of 3.5, which is not a digit. And if you double 7, you get 14, which is not a digit. So 7 can never appear here. Where can 7 then appear in row 1? It has to be here. So this is 7. This 8 eliminates 8 here, so this is 7. This is 8. That leaves 7 not here. 7 cannot be here. Where is the 7 in box 5? Can't be here because of the 7 in the column. Can't be here because of 7 in the row. Can't be here because this is double of another digit. And if it's 7, it would have to be 3.5, or double 7 is 14, and that's not allowed. So 7 has to be one of these two digits, which means this can't be 7, so therefore this is a 7 here. Remaining digits in column 2 and in row 8 are 2, 3, 4, 5. Which means in the rest of the lines, it cannot be 2. It's 3, 4, 5 as possibilities. And a 7. So 7 can't be here. This is 3, 4, 5. 7 can be any of these 3 here. Okay. Where is the 6 in row 7? Can't be any of these because of the 6 in the box. It's one of these two. Okay. We know there's a 3 in one of these digits here in column 2. We know there's a 3 in one of these digits in row 8, which means, and we know there's a 3 in one of these 4 cells in box 2. Well, that eliminates then 3 anywhere else because we have 1 3 here, 1 3 here, and 1 3 here, and they're all separate. So this cannot be 3, and this can't be 3. This becomes a 4 5 pair, which eliminates 4 and 5 in the rest of the column. So this cannot be 4 5. This is 2 or 3. We know there's a 4 5 here. There's a 4 5 here. This is, oh yeah, this is a 3 4 5 7 quadruplet, which eliminates 3 4 5 and 7 in the rest of the row. So this can't be 3 4 5. This must be then 2, which means 2 cannot be here. The rest of row 2 are 1 6 and 9. This can't be 6 here because of this 6. This can't be 9, so this is 1 or 6. 7 has to be one of these two digits because there's only that's the only place for 7 now in row 2. We know one of these digits is 4. 2 of these digits are 4 5. 2 of these digits are 4 and 5. And 2 of these digits are 4 and 5, and 2 of these digits are 4 and 5. That means that gives us 4 4s and 4 5s, which leaves this as a 5, which means these cannot be 5. It's a not 5. It can't be 5, which makes this a 3 4 7 triplet, which eliminates 3 4 and 7 for the rest of the box. Therefore, this must be 5 here. Neither of these can be 5. That leaves a 2 4 pair, which eliminates 2 and 4 in the rest of the box. So this is a 5 here. 2 cannot be here in box 4 because of the 2 4 pair. Therefore, whereas the 2 in box 4, it can only be here. That leaves this as 1 4 6 1 4 6. The only remaining digit now in box 1 is a 3, and it has to be here. So this is 3. Remaining digits in box 2 are 1 2 and 6. So if this is 6, it would have to be with 3. If it's 1, it could be with 2. If it's 2, it's with 1 or 4. So those are all possibilities. 4 and 5 cannot be here. Cannot have 7, 8, or 9 either. 4 and 5 both have to be on this line because there's no other place for it. So it has to be 1, 2, 3, and 6 as possibilities. This can't be 3 or 6, so this is 1 or 2 here. 9 has to be one of these digits, and then we have 1, 2, 4, and 5 as possibilities. And this can't be 4 or 5 because of the 4 5 pair in the column. If this is 1, it would be with 2, but 2 can't be here because of this 2, so this can't be 1. If it's 2, it could be with 1 or 4. If it's 3 or 6, it could be with the other 3 or 6. Okay. Let's see. This cannot be 5 because of the 5 in the column. We have 2 digits here. They cannot be 1 and 2. What are these possibilities? Okay, so let's just count. It's cannot be 1, 2 because that would eliminate 1 and 2 here, and therefore both of these would be 6, which is not allowed. Can't be 2, 4 here because that would force this to be 1, 6. That would eliminate 1, 4, and 6 from that cell. So that's not doesn't work. Cannot be 4, 8 because there's an 8 in the box. So this has to be then 3 and 6. And this can't be 6 because of the 6 in the column. Therefore, this is 6, this is 3. That eliminates 6. That's 3 in the corner. We celebrate because we know we're getting close to solving it. This 1 2 pair is now a 1 2 pair, which forces this to be 6, which makes this a 3. So this can't be 3. This is 4. None of these could be 4, so it's a 3 7 pair here. We can eliminate 3 and 4 here, so this is 2 or 5. 3 cannot be here, so this can't be 6 anymore. Therefore, where is the 6 in row 7? Has to be here. So this is 6. This 1 2 1 2 pair along with the 6 eliminates 1 and 6 here. So this is 4. This can't be 6. This is a 1 9 1 9 pair now in row 2, which eliminates 1 and 9 in the rest of the row. This can't be 1. This has to be 6, which forces this to be a 1. This last digit is a 5, which means this can't be 5 here. Where is the 5 in row 9? It can only be here now. So this is 5. We have, 2, 4, and 7 remaining in row 3. This can't be 7. This can't be 4 or 7. So that makes this a 2 because of the 4 5 pair in the column and the 7. This can't be 2. This is 4. This can't be 2 or 4. So this is 7. This 2 eliminates 2 here, so this is 3, which means none of these can be 3. This is a 2, 4, 5 triplet, which eliminates 2, 4, 5 in the rest of the box. Therefore, this can't be 2, this is 1. This can't be 2, this is 3, which makes this a 1 to 2 ratio of 3 and 6. This 1 eliminates 1 here, so this is 2, which makes that 1. This 2 eliminates 2 here. None of these can be 1 anymore. This can't be 2 because of the 2 in the column, so this must be 9. which makes this 1, which makes that a 9. It can't be 9, obviously. We have a 1, 2, 4. This 4 eliminates 4 here, so this is 2, this is 4, this is 2. We have a 1, 4 pair in row 7, and this can't be 4 because of the 4 in the column, so this is 1, this is 4. This must be 1, 6, and 9 in column 3, and this can't be 6 because of the 6 in the row. Let's see, what else do we have? In column 6, we have 1, 2, and 5 remaining, but this can't be 2 because of the 2 here. So the 1 appears once on this line, the 2 appears twice, the 3 appears 3 times, the 4 appears 1, 2, 3, 4, 5 appears 1, 2, 3, 4, and 5. We're just probably doing normal Sudoku now. This is 1 or 2 here in column 9. This can't be 2 because of the 2 in the row. So this is 1, this is 2. This 1 eliminates 1 here and 1 here. So this is 5, this is 9. This 5 eliminates 5 here. So this is 2. We have 4 and 5 here. This 2 and 5 eliminates 2 and 5 here. So this is 1. None of these can be 9. This can't be 1 either. So this is 6. This is 1. This can't be 3 because of the 3 in the row. And this can't be 5. Therefore, this is 3 or 4 also, but it can't be 4 because of the 4 in the column. So this is 3, which makes this 4, which makes that 5, which makes that a 3. This 3 eliminates 3 here, so it's 7, 3. This can't be 7 here. We have 2 and 9 remaining, and 2 can't be here because of the 2 here. So this is 9. This is 2. That forces this to be 7 and 4. 4 eliminates 4 here, so it's 5 and 4. And we have 6 and 9 remaining, so that's 6 and that's 9. And that's how you solve it. Yeah, pretty interesting. It's basically like the circle counting problem. It's just a line, though. So instead of the circles, it's just, one long line, which is probably harder to pull off, I guess, because you're more restricted in the way that you can form the line, essentially. So interesting use of a counting line. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.